In this lesson, we are going to learn what is SOHCAHTOA and how we can use it to find the missing sides and missing angles of a right-angled triangle. So, let's say for example, we have a triangle like this. We say it is right-angled if at least two of the sides of this triangle meet at 9 degrees. Like in our case, this blue side here meets the green one at 9 degrees, represented by the square, and therefore our triangle is a right-angled triangle. Now, in a right-angled triangle, the longest side, we call it the hypotenuse. Like in our case, the red side is the hypotenuse, and we can denote it by h. Then, these remaining two sides, we name them based on the angle we want to find. Like for example, in this case, this side here, because we want to find this angle, we call it the adjacent. So adjacent is the side which indirectly interact with the angle we want to find. Then the side which doesn't interact with the angle, we call it the opposite, but then the hypotenuse remains unchanged. But in this case, if you were to change the angle and now be interested to find this angle here, then these two lines will also change, and now this one becomes the adjacent and this one becomes the opposite, because this adjacent now interacts directly with the angle we want to find, and now this green one here doesn't interact with the angle we want to find, and therefore it becomes the opposite. Now, with that knowledge, we can be able to apply the logic of SOHCAHTOA, which I've divided here in these parts. So, SOHCAHTOA to find this angle here. So, let's start with the first part, which is the SOH, S-O-H. So, this SOH, S-O-H, is just a shorthand way to memorize that sine is given by opposite divided by hypotenuse. Like in this case, this opposite here divided by this hypotenuse. So, when I say S, I just mean sine. Then when I say O, I mean opposite. And then when I say H, I just mean hypotenuse. So, I can say sine theta, which is the sine of this angle we want to find, is given by opposite, which now is this line here, divided by hypotenuse, which is this longest line here. And from there, I can say, let's assume I'm given the measurements of these two sides. The opposite is 1 centimeter, and then the hypotenuse is 2 centimeter. Then the sine of this angle will be given by opposite, which is 1 centimeter, divided by hypotenuse, which is 2 centimeter, and now it becomes sine theta, which is the sine of this angle, is given by opposite, or the one we said here, which basically means the opposite, divided by hypotenuse, h, the one we said here, which just basically means the hypotenuse, this line here, then is equals to, we already know the measurements of the opposite, which is 1 centimeter, divided by the hypotenuse, which is of course 2 centimeter. So it becomes sine theta is given by 1 divided by 2, which is just half, and half can also be written as 0.5. Therefore, sine, the sine of this angle here, is 0.5. But don't forget, we are interested about the angle, not the sine of the angle. So, to get the real angle, since we have the sine itself, what we need to do is just we need to look for the sine inverse of the sine itself. The sine was 0.5, so we need to look for the inverse, sine inverse of 0.5. So, if we go to trigonometry calculator, we can just select that we want to find the inverse of sine, and our sine itself was 0.5. So what is its inverse? The inverse of that sine becomes 13 degrees, and therefore, if we come back to our question here, then it means the sine of this angle here becomes 30 degrees. And that's how we use the first part, SOH, which basically means sine is equals to opposite divided by hypotenuse, to find the missing angle here. How about if we were told to use, or when do we use the CA, which is cos, basically meaning adjacent divided by hypotenuse? Let's see. For C stands for the cosine, then S stands for adjacent, of course, which is this line here, and then H stands for the hypotenuse, which of course is this line here. Therefore, when I say CA, it's just a shorthand way of saying cos of this angle which we are interested in finding is given by adjacent divided by the hypotenuse. So from there, of course, if let's assume, for example, we have the measurements of these two sides, the hypotenuse which is 2 centimeters, and then let's say the adjacent is given by √3, then the cos theta, which is the cos of this angle here, will be given by adjacent divided by the hypotenuse. But we already know the measurements of these two. We know the measurement of the hypotenuse is 2 centimeters, and the measurement of the adjacent is √3. So we can just replace them here, and now it becomes cos theta is given by A over H, of course, which are these ones now, adjacent divided by hypotenuse, which is equals to, we already know the adjacent is 3. So we replace it with √3 there, then divided by 2, which is the hypotenuse, 2 centimeters. So from there, of course, we can just use a calculator and directly, and we divide √3 divided by 2, which now will give us cos theta is equals to 0.866. But you see, we're interested with this angle. We are not interested with the cosine of that angle. So to get the angle itself, we just need to find the cos inverse of the cosine we got. So it was 0.866. So we can go to the trigonometry calculator and we find the cos inverse of 0.8666. So if we come to the trigonometry calculator, we can just select, we want the inverse of cosine, and our cosine was 0.866. And therefore, if we find the angle, it becomes 30.0029 those numbers, and when we round off, of course, it becomes 13 degrees. So going back to our question here, now it becomes this angle here is still 13 degrees. The way we used sine to find it, it was also 13 degrees, meaning we can still use sine, we can use cos, and we can also use tan to find this angle, just depending on the sides we are given. The sides we are given are the ones which determine the logic we are going to use, whether it is sine, it is cos, or it is tan. So can we try to find the same angle using now tan logic? Just to remind you, tan, TOA, it stands for tangent. T stands for tangent, then O of course stands for opposite, which is this line here, and then adjacent, A stands for adjacent, which is this line here. And if we use the logic of tangent to find this angle, then it means tan theta, which is the tan of this angle, is given by opposite, which is the O, divided by adjacent, which is the A. So now it becomes, assuming we are given the sides as opposite 1 centimeter, and then adjacent as √3 centimeters, then tan theta of this angle becomes, of course, O divided by A, which is opposite divided by adjacent, the ones we got here, which is equals to 1, because we know opposite is 1 centimeter, divided by √3, and we know adjacent is √3. So using a calculator and direct, we can get, of course, tan theta is 0.577. This one, I just put it direct in the calculator. I take 1 divided by root 3. So once we get tan theta is 0.577, we are not interested with the tan itself. We are interested with this angle. But now that we have tan theta, which is of course the tan of this angle, we can find tan inverse of this theta here, which is of course 0.577 from the trigonometry calculator, and we find this angle here. So I'm going to the calculator here. I can just go direct and say, now I want to find the inverse of tan. And that inverse of tan, our value is 0.577. So it becomes 0.577. And the angle becomes 29.9849. And when you round off this one, it becomes 29 rounded off to the nearest whole number, it will be 30. So if we come back to our angle here, it still becomes 13 degrees, of course. So we have used sine, we have used cos, and we have used tangent to find the same angle. Only what mattered is what we were given here. So to use the logic of SOHCAHTOA, it depends on the size we are given and the angle we want to find. That's it for this lesson. Let us meet in the next lesson. We are going to learn about another concept in mathematics. Bye for now.